Hello, everyone. In this lesson, I have gathered some examples from your homework, and we're going to go over them to find antiderivative. And according to the instruction, right, to find the most general antiderivative of the function if it is required so. Just from the previous lesson, we got these formula for antiderivative. Well, for us, the most useful part is really the first two columns. Okay, because once we understand the concept and we know the most general form is just to find the at a constant. Okay, so I'm gonna bring the formula with us. Okay, and so let's put it here. So that's the first two column. And because we know that x raised to the power n is the most general form for power. So we could you could actually delete these rows. We could actually delete these rows, but for convenience, I'm still going to leave as to keep it there. And the other two tables, I'm going to bring them with us. Okay, put them next to each other. And there's one more, just in case we need them. All right. So we got all of these formulas. So in general, you're gonna have those tables with you. We could refer to these columns, refer to these tables, but soon enough that you will find that you're probably not going to need the tables. Okay, so let's look at the first example. The first example says find all the functions g such that g prime equals to 4 times sine x plus 2 multiply x raised to the power 5 minus root x divided by x. Before we start, we need to understand that for antiderivative, we only have addition subtraction rules and a constant multiply function rules. We do not have product rule nor quotient rule. Okay, so we can use these rules to find our antiderivative only in the form of adding, subtracting, or multiply by a constant. Okay, and we can use all of these formulas in any combination that is adding or subtracting or multiplying by a constant. No product rule nor quotient rule. Okay, so with that in mind, we know the derivative. So we're basically trying to find the antiderivative. So g of x, okay, would be the antiderivative, will be the sum of antiderivative of sine x 4 times, so the constant will be kept. The antiderivative of sine x, what is the antiderivative of sine x? The antiderivative of sine x is a negative cosine x, okay? So you can look it up in the table, but I assure you pretty soon you don't need it anymore. So the antiderivative of sine x is negative cosine x plus, what are we going to do about the next part, right? Well, before we do it, we know there's no quotient rule, right? There's no quotient rule. So we need to convert it. We need to convert it into a, addition subtraction form, okay? Addition subtraction form. So we keep the 4 sine x, and we know it has antiderivative, which is 4 times negative cosine x, right? And on this part, we're going to take the x, divide into 2 times x raised to the power 5. We get 2x raised to the power 4, subtracting, okay? And this will be root x divided by x. Okay? Root x divided by x will be, because x equals to root x squared, you can see it that way, or you can work with power, okay? You can certainly work with power. So this will be equal to, 1 root x will be taken away. We just have 1 root x in the denominator. And then we can write this x raised to the power of negative half. Okay, then we're going to find antiderivative for these two. And this obviously we're going to use the power rule. We're going to use the power rule. Okay, so the power rule for x raised to power n is going to be applied. Okay, the power rule. So the antiderivative for x raised to power 4 will be applied here, right? So 2 is left in the front, and for x raised to power 4, right? So for x raised to power 4, you just we want to find the x raised to power 4. So n is 4, right? We plug in the formula. So this is what we got. Okay, 1/5. So it's 1/5 x raised to the power of 5. Okay, you can easily verify that by taking derivative of 1/5 x raised to the power 5, and you are getting x raised to the power 4. Okay. So as we're working on this, we are finding antiderivatives. So negative minus x raised to the power negative half. So this time the power is negative half, right? So all the n will be replaced by negative half. Boom. And negative half plus 1, that's a positive half. Okay, that's a positive half. And so this piece will be just positive half. Okay, and 1/2, that's 2. And x raised to power half, that's root x. Okay, so you can do this on the scratch paper, or you do it along the steps. You can put this answer over here and write another line if you want to. There's a variety of ways of showing your work. Okay, so here you can write -4 cosine x and plus 2/5, right? 2 times 1/5 is 2/5 x raised to the power 5. And last, subtracting 2 times root 5. Okay, or you can write 2 times x raised to the power half. That would be okay too. Then you're done. Okay, so but be sure you express yourself properly. Okay, you don't have to show these works. Okay, if you do, show it on the side. Okay, show it on the side. So basically, you have one piece of paper, right? You have one piece of paper, and if you want to show your work, you can show your work on on just side by side. That would be fine too, or on your scratch paper, because for your reader, mostly we just check your steps. Okay. We could be checking things like here, but make sure your work is proper. Okay. And so this is treated as a scratch paper work. Okay, you can see power rule is being used a couple times over, right? And also the direct application of antiderivative, antiderivative sine x is negative cosine. Don't write this, okay? Don't write this. Don't write it this way, but this way you're telling me, if you write it this way, you're telling me the antiderivative is the same as, antiderivative is equal to g prime. that's not true, right? Be careful on these small details, okay? So these are separate expression, and this is a derivative, and this is the antiderivative. But now, if it is asking for most general, okay, most general antiderivative, okay, if it's asking for most general antiderivative, but if it is asking for a antiderivative, right? If it is asking for an just one of it, antiderivative, right? If you ask for one, if you ask for an antiderivative, for example, then your answer like this will be sufficient, right? You just write g of x equals to that. This is one of the antiderivatives. But if you ask for most general antiderivative, then you will have to write all of that g plus a constant. Okay, plus a constant. So depends on how the questions is being asked. Okay. So now the second one, we're looking for antiderivative once again. Okay. First of all, we know there's no product rule. Okay, you're not going to find derivative of x and then multiply the antiderivative of the one in parentheses. You have to, we only have these rules. Okay, we only have these rules. Addition, subtraction, okay, or multiply by a constant. So to find the antiderivative for this f, you like to write it, you like to distribute it, right? So you're going to write the 12x squared plus 8x. Okay? And then you say antiderivative of f then you say, do we have a notation for antiderivative? Yes, we will soon introduce that, but in this chapter, in this part, not yet, okay? So you just use the word, okay? So antiderivative of f, they will use a capital F, okay, capital F. And that will be equals to, and the antiderivative for each one, right? We're being asked for most general, right? We asked for most general, so we're going to attach a constant. So antiderivative of 12x squared, so we're going to put the 12 on the side, and the antiderivative x squared. We work with that for x raised to the power, 1/3 times x raised to the power 3. So we just put it there, right? Or you can just use the formula one more time. 8 multiply the antiderivative of x is half of x squared. You can see it's convenient if you know the formula pretty well, right? Otherwise, you can just find your own by the power formula, okay, to find antiderivative. And the rest is just simplifying, okay? And here we get 4, and here we get 4. But since this is asking for most general antiderivative, so we should from the beginning add the constant. Okay, so if you don't add the constant, you add a constant later, that would not, excuse me, that would not be good. That would be wrong. So you add the constant at the beginning, okay? All right. Next one. Example number 3, we got x minus 5 to the power of 2. We don't have product rule. We don't have power rule either. Okay, so the antiderivative of f is just, we have to convert it. Right? So for this f, we're going to have to FOIL. So we get x squared minus 10x plus 25. Right? It's antiderivative. We're going to write it as a capital F equals to the antiderivative of x squared is third of x raised to the power 3, right? Subtracting 10 multiply the antiderivative of x is going to be half x squared. You can see this is pretty straightforward. The antiderivative of the constant is 25 multiply x, and the most general form plus constant. All right, so one more step, if you like, would be just, this can be reduced, right? That's 5. Finished. You're done. Okay, so as you get better, you're going to find these antiderivatives with ease. Okay, so now let's look at a couple examples with fractions in the exponent. Okay, so I'm going to bring the formula over with for us to work with. All right, power rule is used very often. It's used very often. So we're going to use, in this case, we're going to use this, twice. We're going to use it twice. And for all of these, we're going to find the most general. Okay, we're going to find the most general. Suppose, you can say the antiderivative of lowercase g of x, and you can call it being capital G, right? Capital G, g of x. All right, it's better you just tell the reader what you're doing. And the antiderivative, right? So we got power, another power, right? So we got 4. We put the 4 on the side. And for x raised to the power of a negative 2/3. Oops, sorry. Okay, the power is negative 2/3. As long as n is not -1, we can just use it. So for this formula, right, everywhere n will be replaced by negative 2/3. Boom. All right, and you simplify negative 1/3, negative 2/3 plus 1, that's going to be 1/3. Right, 1 over 1/3 is 3. So this power is going to be 1/3. And 1 over 1/3, that's a 3, right? So you can put this right there. Okay, or you can derive that process over there. Okay, subtracting 2 times the power this time is 3/5, right? N is 3/5. So this is 3/5. This is 3/5. Okay, you can actually move this part of the work over here. Okay, you can do the same over here, right? For example, here you can write it as, negative 2/3 plus 1, right? And x raised to power of negative 2/3 plus 1, right? You can do it this way, okay? So that way you would not need this piece, but either way is okay. Either way is okay, as long as you know what you're doing. Simplify, right, for this part. And we have done that before. So this part was 3. And so this is going to be 1/3. Okay, positive 1/3. So that part is done. So let's continue with the latter term, right? So on this piece, you have to operate on the fraction, right? So 1 is equals to 3 under 3, 3 over 3. So get the same denominator. So this is going to be 8 over 3 after addition of these two fractions. And then 1 divided by 8 over 3, that's going to be 3 over 8, right? You can see that operation. Over here, you're going to add up the exponents, which is going to be 8/3, right? And plus the constant, actually at the beginning, plus the constant at the beginning. Don't forget that, okay? And the next step, simplify. So this is 12. You can see the major work is the one we apply the power rule. And now 2 and 8, so that will reduce. So that's going to be 3/4. Oh, sorry. Hold on. This is going to be here. And that one was going to be there. Wait a second. I think I need to do some reducing, okay? Cut. Subtracting. Where did I get the 12? Sorry. Wait a second. The software is it's not working for me, huh? All right, so let's do it again. Simplifying. So this is 12. And this is 3/4. Okay, so this is 4. Sorry about that. Well, this software actually, I don't know when it's going to die. The company already has declared bankruptcy, and but I haven't found another software that I can use so conveniently and type so neatly. But anyway, so until then, I will continue to use it. Okay. So once again, if you wish to practice and if you want to do it, you can pause this recording and do it your own, right? So this is one more time. We're gonna try it. We're gonna use a power rule one more time. Okay, so let's see. So we're gonna write this time antiderivative of f of x, right? So that's gonna be, we can use capital F, or you don't have to use any symbol. Okay, f of x. And to make the power, since we are going to use the power rule, right? So you may like to rewrite the f. You may like to rewrite the f, so you can use the power. Okay, so 3 times, right? X raised to the power of half, right? Minus 2 times x raised to the power of 1/3. Okay, if that make it easier for you, then you don't have to do that. You can just directly, do it to find the antiderivative. And the antiderivative of x raised to the power half, right? So let's apply power rule. And so you're gonna get pretty soon, you will not need the formula, right? So it's the power is half. So 1/2 plus 1 in the denominator, multiply x raised to the power of 1/2 plus 1. Okay, be careful about the alignments. When you write your work, okay, the equal sign should be lining up with that fraction bar that is in the center. Okay, make sure you have that proper alignment. Okay, and then subtracting 2 times, right? And 1/1/3 plus 1, right? X raised to the power of 1/3 plus 1. So these two are always the same. Notice this number and this number, the power is always the same. Okay. And the rest, and that was spelled out in the, don't forget the constant if you ask for most general. Okay. If you don't need the most general, you don't need a constant. Okay, we'll encounter that in later. So I'm gonna bring the formula one more time with us. Okay. Just for our convenience. Okay, I know pretty soon you would not need it. All right, simplifying. So this will require some, your arithmetic skill. Okay. So 1 is equals to 2 over 2, 2 under 2. And so this will make 3 half, right? 3 half. 1 over 3 half is 2/3. So this is going to be 2 over 3. And this power is, of course, is 3 half. 3 half. Okay. Over here, the denominator is a 3, so you have a 3 under 3, that's a common denominator. So here is going to be 4 over 3. And 4 over 3 is going to be the power, right? Because these are the same fractions. And the 1 over 4 over 3 is 3 over 4. Okay? And last step, simplifying, we're almost done, is 3 times 2/3. That's going to be 2. And over here, 2 times 3 over 4. And 2, take away the 2 in the 4. So we get 2. So 3 half. All right, it takes some patience. Then you get your antiderivative. All right, so let's look at example number 6. Once again, there's no product rule for antiderivative. So we have to, convert G in the form of adding, subtracting. Okay. And you can write it as 2 times root x, or 2 times root raised to power, 2 times x raised to power half, minus x times root x, right? You'd like to write it in power form, which is, this is power 1, right? Root x is x raised to power half. And then we just add these 2 powers. And I think I'm sure you guys know how to do this, but it's just in case. Okay. And so that's going to be x raised to power 3 half. And next will be 6 times x squared and multiply root x, right? And so that's going to be root x like this. So it's 2 plus half. That's going to be the power is 2 plus half. So that's, that's going to be 5 half. So before we write the antiderivative, we write it as sum and differences. Okay, antiderivative of g of x, lowercase g. Okay, and you can just go for it, right? That's 2 times, 2 times the antiderivative of x raised to the power half. We've done that earlier. You don't have to use capital G of x. It's optional. Okay, it's optional. So in this example, I'm not going to use it. Not going to use it just to show you. Okay. Once again, it's 1 over. You can write 1 plus half, right? And the power x raised to the power of 1 plus half. 1 plus half. There. Okay. Subtracting, right? And the antiderivative of x raised to the power 3 half. Whoops, I'm sorry, I put it in the wrong place. Okay. So that's going to be 1 over 1 plus 3 half. 3 half. It's 1 plus n plus 1, the same thing. Okay. So x raised to the power of the same number as in the denominator. Okay. Plus the 6 multiply the antiderivative of x raised to the power 5 half, right? So that we're gonna get 1 plus 5 half under 1, and then x raised to the power of 1 plus 5 half, okay? Because that's the power rule formula. So we're going to use this. You can see the denominator here is n plus 1, n plus 1. Sometimes people like to use 1 plus n. That's what I did. Okay, that's what I just did. Same thing. No difference. Okay, so whether you do n plus 1 or 1 plus n, it makes no difference. Okay. Equals, don't forget the constant, right? Don't forget the constant for the most general, okay? And then the next step, you will simplify, okay? You will simplify. We do expect you to be able to simplify. You will know very quickly that we do need this, okay? We do need this. This is going to be 3 half, right? 1 over 3 half is 2 over 3, okay? And this is going to be 5 half. 5 half under 1 is 2 over 5. And so this is going to be 5 half. Okay? And this fraction is going to be 7 half, right? Because 1 is 2 over 2. So this is going to be 7 half. So this is going to be 7 half. Okay? 1 over 7 half is 2 over 7. And almost done. Almost done. Okay? And the 2 times 2/3, that's going to be 4/3. 2/5, right? So this is 3, this is going to be 3 half. Okay, we could have done that sooner, right? So 3 half, right? We could have done 3 half here, by the way. We could have done 3 half here. All right. This part is done, nothing to be done. And 6 times 2 over 7, that's going to make it 12 over 7. Done, finished. Okay. So next, example number 7. Okay, example number 7. How do we handle the antiderivative, or the most general antiderivative of this form? Obviously, there's no quotient rule, so we're going to have to write it as a sum and addition. So the numerator, each term will be divided by root t. Okay, so every term will be divided by root t. Okay, so this root t is going to divide into each one. And you may like to write in this step the power form. Okay, but we can write the power form in the next step. Okay, so this is 2 times root t. So you're going to have 2 t raised to the power of 1 minus half. So that's going to be half. Right? Subtracting 4 times t raised to the power of negative half. All right? Plus 3 times root t divided by root t, that's going to be just 3. So now we can find the antiderivative. So antiderivative, the most general form, right? We don't have to introduce a symbol to show it, right? So the antiderivative, we're going to get started. So 2 multiply, we've done this too many times, right? So we just have to use that one, right? Except we're going to have to change x to t. All right? Minus, this is 4 times, right? This time the power is negative half. So that's gonna be 1 plus negative half under 1 t raised to the power of 1 plus negative half. Plus 3t plus constant. Continue, simplify. And this is going to be 3/2 and 2/3, right? So this is going to be 2/3. We are pretty familiar with that. So this is going to be 3/2. This is going to be negative. This is going to be positive half. Okay, this is going to be positive half. And 1/2, that's a 2, right? 2 times 4 is 8. So here you could simplify this already, right? You can simplify this already. So equals to, right? So that the top equals the bottom. And this is going to be positive half. Okay? 3t, done. Finished. Finished. Okay, so I can literally see, I know you guys will get better at this soon. All right. Number 8. Okay, number 8. We got 2 roots. Fourth root. We don't need to do any preliminary work. It's already in addition, but be careful, right? This number is a constant. Fourth root of 5. Okay, fourth root of 5. So the antiderivative, okay, of this lowercase f would be, this is a constant, okay? So it's just multiplied by x, all right? Plus x raised to the power fourth root, right? So you're gonna have 1/1 plus quarter as the power, right? And x raised to the power of 1 plus a quarter. Almost done, almost done. So that's one term. Don't forget the constant, right? Plus the second one, okay, plus 1 plus 1 quarter is 4/4 plus 1/4. So this is going to be 5 quarters, okay, under 1, and x raised to the power of 5 quarters. Okay, 1/5 quarters is 4/5. All right, plus constant. Done, finished. Okay, so number 5 is done. Let's look at number 9. Number 8 was done. Number 9. If you're given this form to find antiderivative in the most general form, you may like to convert it. Here we're told x is positive. Okay, so before we do anything, and we got 2/5. You know what? I'd like to separate that number 2/5. Okay, multiply 1/x. Okay, so I'm not going to use power because for 1/x, right? We cannot use the power rule. We got 2 of logarithm, but because we know x is greater than 0, so we can use ln. We can use this one. Subtracting this one, we can use power. So we minus 3 x raised to the power of -2. So now as we write down antiderivative of lowercase f, okay, suppose this time we're going to use some symbols to represent our notation. And that's going to be, oh, sorry, this is 2/5. My bad. 2 over 5. Okay, so 2 over 5 we get to keep. And the antiderivative 1 over x, when x is larger than 0, that's ln x. Subtracting the antiderivative x raised to the power negative 2. So we're going to use the power rule. Okay, so over here, we're going to get 1 over 1 plus negative 2. And x raised to the power of 1 plus negative 2. And of course, you know that's negative 1, right? So let's just write one more step. In your work, you actually can just go to, from here, go to this step directly, okay? I'll show you what that is. Negative 1, you can go here directly because I'm sure you guys are getting better. 1 over negative 1, that's negative 1. Negative 1 times negative 1. Negative 3, sorry, that's a positive 3. So we're almost done. So for 1 x raised to the power negative 1, you can write 3 over x. Okay, plus the constant. Don't forget plus the constant on the first step. Done. Finished. Okay. Number 10. Number 10. So get to use some other functions. Okay. Example number 10. On this one, it's almost pretty straightforward. Okay, except that you almost don't need this step, by the way. Okay, 10 multiply x raised to power of negative 6 minus 2 times e to the power x, right, plus 3. The antiderivative, oh, sorry, why did I get that? Okay, change the fonts, okay, of lowercase f would be, right, capital F equals to, right, 10 multiply x raised to the power negative 6. We use the power rule, right? So so you can see the power rule at work, okay? 1 over negative 6 plus 1, x raised to the power of negative 6 plus 1. Then you can say, hey, I know how to just negative 5. So you can do this directly, and you can get a negative 2 right there if you want. Minus 2 times e to the power of x, because the antiderivative of e to the power x is e to the power x, plus 3x plus constant. Done, finished. All right. Okay, we got 5 more. And these functions that you will see varieties. We're going to see varieties. Okay. The antiderivative sign, we know that, right, is negative cosine. The antiderivative secant times tangent, secant times tangent, secant times tangent, right there. So the antiderivative for this one is actually very straightforward. Okay, the antiderivative for this one is very straightforward if you know the formula. Since we have derived in the previous video how to come up with all these antiderivative table, I really hope that you've done that. You don't really need to memorize any one of these formulas, okay? Because you can derive it when you need it. So capital F of theta equals to 2 times, right? The antiderivative of sine is negative cosine. So just put it there, boom. Minus 3 times the antiderivative of secant times tangent. Secant times tangent is secant. plus a big constant. Finished. We're finished. We're done. Except that here you want to simplify that. That's going to be -2. Okay, finished. All right. 12. We already did 11. So let's do 12. Okay. Secant squared. The antiderivative secant squared is tangent, right? So we have the antiderivative of secant squared is tangent. Right there. Okay. And what else? The antiderivative of cosine is sine, right? So this answer is also most straightforward. So we can write down antiderivative of h of x is, right, is basically tangent of x plus I is a constant, okay? The antiderivative cosine is sine x plus a big constant. Okay, example 12 is done. So we got 3 more. Okay, so let me bring them up to here. 13. Okay, 13. 13, we have two functions, and function is f is a function of r. So r is the variable. So 1 over 1 plus r squared is more like the formula we use. 1 plus, I think we have those formula, okay? I just didn't bring that here. So let me find them. They are there, right here. Okay. So these formula are what we're going to need. Okay, put it in the front, right? Okay, number 13, right? The antiderivative of 1 over 1 plus x squared, okay? You know, it's most convenient to know this formula actually, because this is used often, okay? Arctangent. So we have arctangent r for this, and the other one, we're going to write it as a power. Okay, so we're going to keep it because we already know it's antiderivative minus r raised to the power of 4/5. Okay, fraction power. Okay, so the antiderivative would be capital F of r equals to, right? So we get arctangent of r subtracting. So we're going to use a power rule for this piece. Okay, that's going to be 1 over 4/5 plus 1 r raised to the power of 4/5. Wait, sorry, 4/5. Okay, plus that big constant. Simplify, just one step away. Okay, simplify. This part is done. So here we have 5 over 5 for 1. Right? So that's going to be 5 under 5 plus 4, that's 9. 1 over 9 over 5 is 5 over 9. Finished. Okay, number 14. Okay, number 14. You see, we get to use the antiderivative of cosine, but this is g of v. So v, it's a variable of g. Okay, the antiderivative 1 over root of 1 minus v squared, right? So we can use either one of these. We can use either one of these. And you really can use either one, okay? But I probably will use this one because, you know, it doesn't have a negative sign. It just looks a little simpler, okay? All right, so the antiderivative of g of v, then we will get capital G, if you like, of v would be equal to 2 times the antiderivative of cosine. The antiderivative cosine is sine, right? Sine x. All right, subtracting 3 times, okay, arc sine, plus that big constant. The last one actually is, there's a little challenge in here. Okay, because in turn, how do we break it up? How do we break it up? Break it up, right? We know there's no quotient rule, there's no product rule, right? So what can we do? Okay, you may like to pause here to see what you're going to do. Okay, so then come back. Now, suppose you're coming back from, 2 minutes of trying this. So this is my answer. Before you do it, we're going to take x squared plus 1. We're going to take x squared plus 1, divide into something, right? Divide into the numerator. So we got the denominator x squared plus 1. Okay, on the top, what I'm going to do is I'm going to do 2x squared, 2x squared plus 4 plus 1, plus 4 plus 1, sorry, plus 4 plus 1. Why do I do this? Okay, you will see. For 2 times, oh wait, I'm going to do 2, sorry, 2 plus 3. How about that? 2 plus 3. Okay, 2 plus 3. 2 plus 3 is 5. But why do I break it up that way? So that way I can factor out the 2. So these will be combined. So 2 will be factored out. So when I take x squared plus 1, divide into these 2 pieces. Okay, so this is how I'm going to divide. So x squared plus 1 will divide into this piece, and we'll divide into this piece. And what do we get here? We got 2 plus 3 over x squared plus 1. So that's how we're going to break it up. And now the antiderivative will be most obvious. Okay, the antiderivative of f would be 2x, right? 2x, that would be, I'm going to write it as 2x plus 3 times arctangent. Okay, so it does take some algebraic maneuvering to get most of these antiderivative done. We will need these antiderivative till the end of semester, until the end of semester, and you will continue to need them for Calc 2, Okay, thank you for watching.